Our technology at Interpretable AI is based on years of research at MIT. So our core product, Optimal Decision Trees, is able to produce a simple decision path that human can follow that mimics the human decision-making process while maintaining the same level of performance similar to deep learning systems.
So traditionally, practitioners have had to choose between models that are interpretable and models that have good performance. So the interpretable models that have existed out there in the world for the last 30 years don't reach the same level of performance as deep learning or boosting. Optimal Decision Trees harnesses the power of modern optimization and years of research at MIT to bridge that gap and simultaneously delivers full interpretability at the state-of-the-art performance that we've come to know from deep learning and boosting.
So going to the healthcare model for surgical risk prediction, on the one hand, you have this very simple logistic regression model that does not capture all the nuance and the nonlinearity between the variables, and the predictive power is generally poor. On the other hand, you have these deep learning systems that may give you a pretty good prediction, but there's no way to really look into why it's making that prediction. You don't really know what are the important variables, how the variables interact with each other. Doctors cannot really inspect whether this thing aligns with their medical training or not. So we go right in, we take the both benefits from both the simple approach where people can look into and also the high performance from the deep learning system. And we generate a simple tree where the doctor can follow the first split on a variable that is aligned with their variable and continue on so that it comes to a prediction and they know exactly what's the logic behind why the model made that prediction.
The thing that sets Interpretable AI apart from other approaches to interpretability in artificial intelligence is that we build models that are interpretable from the beginning and really push the performance to the limits. Other approaches just take these existing neural nets and try and make them interpretable after the fact. And for that reason, they never really achieve true interpretability. They're just trying to explain what their model is doing. Whereas our models, we can explain from the get-go exactly how they are.
So for instance, there are people who try to explain a risk scoring system in banking. So they train a deep neural network and they predict this person has 80% chance of default. And at that point, they try to put some interpretability using these kind of post hoc analysis approaches based on the result. But their explainability is still at a very local level. It is for people who are already in that group, given their demographic and their past history, then trying to see the impact of certain variable within that very narrow group of people. Whereas if you had under our optimal decision trees type approach, you can see globally why that person falls in that group and what's the decision that was being made to segment people the way how our model did it. So our interpretability, as Jack was saying, is really built from the ground up, is global, and can be explained to everyone in the population.
So we met in the operations research program at MIT when we were doing our PhDs. And we saw that there's a wealth of research coming out of the group there in particular, but also the wider research community that's just not making it to the business world. There's so many different techniques and methods and ideas that have real business value, but they kind of just get published in academia and that's the end of it. So we decided that we really want to take some of these ideas that can really change the way the business world operates and bring them out to the world to create that value.
The implementation, a good implementation of a good idea is actually very difficult and was not really incentivized so much in academia. So that's why a lot of times great idea just stops at the paper publication step. For us, since we really believe in the business impact of making this algorithm to to perform at the level that it should, it really takes a lot more effort, engineering effort, a lot more design for that to work. It is something that we're good at and that we really strive to do. So take out our Interpretable AI software modules, for example. It's the two products that came out of our respective doctoral thesis research, and we put a lot of effort in making it scalable, making it fast, making it work with real data, given all of the nuance and complexity in the data set. That's why even just during our research and research engagement at our PhD project, these software modules have seen a lot of impact. So we believe taking the same approach and doing it to some of the other interpretable methods coming out of research can deliver just as much impact.